Hello friends, today we're going to be doing topic 2.1 part 2, which is just a continuation of what we were looking at before, geometric sequences this time, focusing on that, just one page of notes, still using Bryan Passwater's wonderful material that he's provided for free, so thank you for that. And so here we go. Geometric sequence, the way the geometric sequence works is that there's a common ratio, right? So we're multiplying by the same ratio every time. And so there's the general formula, which we saw. I should be writing this, right? G of k, where, G of k is the kth output that we have. And then n minus k, n is the nth term, k is the kth term, whatever it might be. So they want us to find an equation for the geometric sequence with g of 3 equals negative 3 and r equals 10. Okay, so let's use, so g of 3, or rather g of n equals, so g of k, so we're using g of 3, so this is just negative 3, right? R is 10, so 10 to the n minus 3, right? K is 3 here, so k is, so that's it. That's our general equation. So let g of n be a geometric sequence with g of 2 equals 24 and r equals 1/2. Find an expression for g of n. Use the expression for gn to find g5. Okay, so g of n equals, let's see, g of 2 equals 24. So we put in 24 here. R is 1/2. And then we're going to use n minus 2, because it's n minus k. So that's our general. And now we want to find g of 5. So what we're going to do for this, we just plug in. So g of 5 is 24 times 1/2 of 5 minus 2. So this, when we do this arithmetic, it's 24 times 1/2 to the third power, and it all turns out in the end to be 3. Okay. So those are a couple of examples, pretty easy from what we learned in part 1. But now, what happens if we have two terms but not the value of r? So what we do is we set up the same kind of equation that we just had, except this time we can put in the various values that we have and then just solve for r. I think this probably best comes out in doing the solutions, right, or in doing the examples. But, like it says here are the steps. Use both terms to create one equation in the general form. Use the larger k value as the gn term. And this is modeling what we did for the arithmetic sequences, right? We did the same sort of thing for the arithmetic sequences in part 1. And then it says solve for r using the equations created from step 1. And then you can use the value of r found in step 2 with either term to write the general form of the equation out of that. So here's an example. Let gn be a geometric sequence with g of 3 is negative 2 and g of 6 is 128. Find an expression for gn. Use the expression for gn to find g11. Okay, so what we're going to do here, we take the general form, let's just write it out. G of n equals g of k, r to the n minus k. Okay, and we're going to use g of 3 as our k, right, sort of our new base, and then g of 6 as our n. Right. One way to look at this too is that if I do 6 minus 3, then I'm going to get a positive number in the exponent here, which is kind of what I want. That's the general pattern that we have, at least so far. So now I'm plugging things in. So g of n, that's g of 6, is 128 equals g of k, so that's negative 2. R we don't know, we're looking for that. N is 6, and then the k is 3. So I simplify this, I get 128 equals negative 2 times r to the third power. So now I'm solving, so I divide both sides by negative 2, and I get negative 64 equals r to the third power. So I'm going to take the cubed root of negative 64. tell you what, I like this better, negative 64. The cubed root, I like to write it as something to the 1/3 power, if I can write it the right way. That's the same thing as cubed root. I don't like the root symbol. I prefer this, but if you like the root symbol, you can use that. It's a standard convention. Anyway, negative 64 to the 1/3 power. And what that gives me is negative 4. Okay, so r equals negative 4. Good. So now I can write a general form of the equation. So g of n equals negative 2 times negative 4 to the n minus 3 power. That's what my new equation looks like. And now I can do this to find G11. Right, so let's see. G of 11, so the output of the 11th pair in the sequence is negative 2 times negative 4 to the 11 minus 3. When you do that arithmetic, you end up with negative 131,072. Okay, so here's another example. It says, let g of n be a geometric sequence. G of 2 is 48, g of 7 is 1.5. Find the expression for g of n, and use the expression for gn to find g11. Same idea as what we did before. This is going to be our k, again, kind of our new base. And we're going to treat this as the n, so the nth term in the sequence. The general form looks like this: g of n equals g of k, r to the n minus k. G of n is 1.5 equals, this is 48, r to the 7 minus 2. So here's one way of doing this. 3 over 2 times 1 over 48 equals r to the 5th power. So what I end up with is 1 over 32 is r to the 5th power. And so 1 over 32 to the 1/5, so I'm taking the 5th root of 1 over 32. So the 5th root of 1 over 32 is 1/2. So 1/2 equals r. The general form of this equation then is g of n equals 48, or what we can write as a general form, times 1/2 to the n minus 2 power. Great. And now I can use this to find G11. So G11 is 48 times 1/2 to the 11 minus 2 power. And when you do the arithmetic with that, it turns out to 3 over 32. And that's it. That's all of lesson 2.1, part 2. Just examples of how to find geometric sequences when you're not given the ratio, but you are given 2 of the terms in the sequence. So again, thanks for watching. Don't forget to like and subscribe.